Hi everyone. Today I will be discussing about the project of Boston housing data set, which is a project in machine learning. So I had taken a course from Skyfi Labs, and there is a course completion project on Boston housing, and I have to explain that. So let's begin. I will open the Jupyter notebook and then I will open that. Where is that? Yeah. So let's begin. So in machine learning we will discuss about Boston data set. So in this, what we do, the target house prices are given and some features are given that the house prices depend upon these features, and we have to use machine learning and we have to feed that given data to the machine, and then we have to make predictions for other houses in that society. So for that we need to import NumPy, which is numerical Python, for using numerical operations, and then pandas as PD, and this is for loading the data set, making data frames, loading the files and all that. So this is very useful. These two libraries are very useful. Then it comes to this matplotlib and pyplot. So these are actually visualization libraries. Okay, so this is also visualization library. So next, sklearn. Sklearn is a library in Python which is a machine learning library, and Boston dataset is actually present in sklearn itself. So we will directly import it from here, from sklearn.datasets, import load Boston. Okay, so then sklearn, there is a mean square error, and then train test split. Actually at this time just look at it. Later on I'll tell what this does and what this does. So okay, so here we have imported the load Boston. So we will take it in a variable Boston. So sorry, I didn't execute this shell. Now it is okay. So now I will describe this because we don't know what is there in this data. So now we will describe this data here. Yes, so this is there in data. So CRIM, this is just the heading of that data. So CRIM means per capita crime rate by town, that how many crimes are there per capita. Okay, so this feature will affect the house prices. If someone have to buy a house in some society, he has to see that whether there is a crime rate, high crime rate or low crime rate, right? So similarly there is many other, like RM, average number of rooms per dwelling. Okay, and then RAD, index of accessibility to radial highways. So all these will affect the prices of the houses. So what we have to do now, there are many features, but we have to take one feature on which the house prices depend the most, right? So okay, we will get to that also soon. So now from this, actually this data set contains features as well as target, because this is this we are using we will be using supervised machine learning here, right? So in supervised machine learning, what happens, we provide the pairs of what, input and output, right? So output is also there in the data and input is also there in the data, and machine has to be trained using that data, and then later on machine will work on the testing data. So here I am gathering the features from what, Boston.data, and columns I am naming what, the already named Boston.feature names itself. So I will execute this. Now features.head, I am printing, and the head is used to print the first some element. If I use only head, then it will print the first 5 elements, and if I use any integer here, and it will print that number, that many rows. Okay, so we can see from here. Then target, we have gathered the features from the data, right? Now we want to gather target also. Actually we are making two different data frames from the same data set. Okay, So we will print this also. Yeah, so here just I am finding the maximum of target and minimum of target, which is 50 and 5 respectively. Then instead of doing this maximum minimum, if I need to find count and standard deviation, then 25 percentile and all that, directly I can do what? Target dot describe. So this will describe whole of the data, right? This will describe whole of the data. So how many total data set is there, how many rows are there? 506 rows. What is the mean? This is mean, and this is standard deviation, this is minimum, and this is maximum, this is 75 percentile and all that. Okay, so now I will do what? I will concatenate features and target, and axis 1 means according to the columns, axis 1 means column wise. Okay, so I am just merging both of them again, and this will be a one data frame now. So yeah, see, earlier there was no target. If I go back to the what if I go back to the features, then you can see that there is no target column at the end, but here the column target is appended here. Yeah, right. So now we will go to data visualization. Now data visualization is similar to like this describe only. This visualization means we are visualizing whole of the data, right? Mean, standard deviation, everything. So if I do the df dot describe, it will describe whole of the df data frame, right? It will describe whole of the data frame. Yeah, from here you can see mean of CRIM is crime per capita is yeah, this 3.6, mean is this, and for ZN mean is this, for Indus mean is 11.13. yeah. So now earlier also I told you that we will find that attribute which affects the prices the most, right? So here that is called correlation between two variables. So correlation, here we will use Pearson correlation, which is already present in Python. Okay, so here we are doing core equal to df dot core Pearson. Yeah, and we will get correlation. Yeah, see, correlation means relation between two variables. So here what is happening? Relation between CRIM and CRIM, relation between CRIM and ZN means for each variable it is showing the correlation for all other variables. So for now this tax versus all variables, rad versus all variables, but what we need all variables versus what? Target, not all of them. So we need only this row and this row. So that's why what we will do core equal to AV as absolute value of what? Absolute value of core attribute. Attributes means this thing, then target. So what is target? Target means here. So this thing and this thing we will get for attribute in list of features. Yeah, you saw this thing, features earlier. Then yeah, if I execute this, I will get core is this. So this is the only what you can match 0.388 and 0.388. It is negative and it is positive because we took the absolute here, right? So 0.36 and 0.36, 0.48, 0.4. So this row, this column, target column is with these features like CRIM and target relation, ZN and target relation, Indus and target relation. So this is the only column that we require. So yeah, we got CR here. Then what I will do, I will make a zip of what? Features and core, because this is only core. I don't know this what is this for, means I don't know whether this is for CRIM or ZN or what. Okay, so that's why I will append both of them, and that appending I don't want to use dot append that way, okay, because that will append at the last. So I will make the pairs, and pairs in Python are made using the zip function. You might know this. So zip function, and then if we execute this, I will get this. So now I can understand that this 0.388 is for CRIM versus target, and this is ZN versus target and all that. Now I want to sort according to the this this numbers I want to sort. That's why I'll use L dot sort. This is L, this is L, and I want to use L dot sort, but in decreasing order, right? Decreasing order. So this will sort in decreasing order. You can see 0.73, 0.69. okay, so now yeah, this is unnecessarily. Okay, so cost dot labels, yeah, again I will unzip. Earlier I zipped it just to sort it. Now I have sorted. Now what I want to get is only value. That's why I'm again unzipping the pairs. So these are unzipped pairs. Now these are labels. I gathered the unzipped pairs in cores and labels. If I print cores here, I will get this. If I print labels here, I will get this. So now I want to plot this, because yeah, manually also if you just see that 0.73 is the highest and this is for LSTAT, yeah, from here also I can get. But in machine learning, if you visualize, it is very good, because visualization is a good technique, because if you have lakhs and lakhs of data and it is harder to directly manually see and get the inferences. That's why we visualize using the using the libraries like matplotlib or simply other libraries. Okay, so here I'm using plt.figure. so figure size I'm setting 15 by 5, then index n pi equal to n. So this index is from here, yeah, 0 1 2 3 4 5 6 7 8 like this. Okay, and this will be till what, how many levels are there. So that's why I'm taking till length of levels. Okay, now I want bar chart. Okay, this is bar chart. Index, first x value will be index and y value will be cores. Wait, what I said, yeah. So then x value will be index and y value will be cores. So then using x level, what x level I need? Attributes. Okay, attributes, yeah, here you can see here you can see attributes. Then correlation with the target variables, this will be in y level, yeah, you can see here. So x ticks, what are x ticks? X ticks are actually these things: lstat, rm, and index, stacks, and crm, these things. So using x ticks, I'm writing at the place of index, I'm writing labels. Like at first index there will be first label, at the second index there will be second label. So first lstat rm, you can see from here, lstat rm 0 1 2 3. Instead of 0 1 2 3, I'm just writing these thing labels. So to get the well pictorial graph. So then normalization. Normalization. Yes, so normalization is to bring the data on the same scale, because these two data, that lstat data and target data, do not have the same scale. So we will need to bring them to the same scale so that it is easier for the algorithm to grab and make a command on the data. Okay, so here we will use min max scaler. So what does min max scaler does? I have written here min max scaler, and for each value in a feature, min max scaler subtracts the minimum value in the feature and then divides by the range. Okay, so it will subtract the minimum value of the whole array and then divide by the whole length of the array. The range is the difference between the original maximum and original minimum. Okay, so the range will be between this only. Min max scaler preserves the shape of the original distribution. So shape will be preserved. Yeah, it means that the values may change, but the ratio between the data will not change. So here I will take x scaler as min max scaler. I will take the object of min max scaler in x scaler. So x scaler dot fit transform. Fit transform will do what? It will fit and transform the data, that is normalize the data. So directly it will normalize. We don't need to do it manually, only we need to call the function and it will do. So here this fit transform function expects what? Vertical values, vertical array. So that's why we need to reshape that array. -1, 1 will reshape the array in one column and n rows, whatever are the rows. So that's a -1. -1 means default value. Any number of rows the data has, it will be built on that. So similarly for the y, okay, and then this is again converting it to the real dimension. So here we will print see, now it is between 0 to 1, range is between 0 to 1. Here it was 24, 21 and other values, but here it is normalized now, it is between 0 and 1 only. Okay, so if again I will transform back to the original data, it will be this only. So data is not lost actually. Okay, data is not lost, only its ratio is decreased. Now data splitting, I need to split the data for see, there are three types of data. One is one is training data, then it is testing data, then third is prediction data. So here what I will do, I will break it down in x train and then x test and y train and y test. What is x train? X train is lstat data. Okay, here we have taken where is that? This lstat data. And y train and y test is the target values. Then test size. What is test size? It is 0.2. okay, it means the test data will be 20% of the whole data, and the rest train data will be 80% of the whole data. So here that's why I have printed this length. So length will be 404, which is the 80% of the total length, which is 506. So let me execute all these values again if I have missed executing them, because next shells will not work otherwise. So now what we will do, we will use the linear regression. So linear regression means to find the fittest curve, of the data, and that curve will be the prediction line. Means that if we put any value, so our predicted value will be on that line. Okay, so there are three functions in gradient descent. We will use the gradient descent algorithm here. So there are three functions: update function, alert function and gradient descent function. So what is update function? Update function, first I will tell a little about update error, then we will come back to this when we will come to gradient descent. So update function takes the m, x, c and t. What is m? M is the initial value of slope of what? The line, the slope of the prediction line. So this is slope and this is intercept. So x is the x is the lstat value, normalized lstat value, and t is the target value, and this is learning rate. This is the learning rate means iterative steps, that how we need our machine to learn. So it can be again split into three, that is too low, just right, and too high. If it is too low, then it will take a lot of time, because there will be a lot of iterations. So second one is medium. Medium means neither too low not too high. So if it is too low, it will take a lot of time, and if it is too high, then it may not give you the proper outputs. Okay, so that's why we need it to keep the medium only. So gradient m variable we will take, and we will calculate the gradient. So you can go back, you can go and Google for this formula, and this is for gradient. Okay, actually how this is found, I will tell you. Gradient descent algorithm. So there is a what is equation of line, that is y equal to m star xi plus c, that is m into x plus c. Then there is a mean square error formula. What is that? 1 by n into that is average of y minus y of I whole square, where y is the given values and yi is the predicted values. That is the difference between the given values and the predicted values. That is the square of whole is mean square. You can see the formula by googling it. Okay, then we will put this formula in line and we will differentiate it and we will find delta m and delta c. So what is the delta m and delta c? The delta m and delta c is here. Delta m and delta c is actually the update, that is the change in m and c that we need to make in every iteration. Okay, so that is delta m and delta c. So here what we are doing, we are multiplying grad m with learning rate. So learning rate will affect the change, right? If the I told you it is too large, too low and the medium. So if the learning rate is too large, so then the subtracted value will be too large, right? Subtracted value will be too large. So if it is medium, then it will be medium. If it is too low, then it will take a lot of time to reach to the equilibrium value of m or c, required value of m or c, where the loss function is minimum. So this is where a learning rate comes into picture. Then error. So here error, in error we will you can also see the formula for this, and this is m cross x plus c, which is the equation of line. Actually this also we have got by putting into the putting the line equation here. Okay, minus t, that is target, that is y minus yi only. What is y here? Equation of line, that is m star x plus c and minus predicted value ka whole square. Then we will divide it by 1 or 2 star n, that is n is the total length of x. So and then yeah, this is important now. Gradient descent algorithm, how this works. So it takes the parameters like initial m means initially we need to set some value for m and c. Now it depends that if you take the value closer to the value of m and c that we have to get at the end, then it will take less time, but this is very difficult to choose m and c initially. So that's why we take m and c randomly. Then x is the L-stat value, and that is the most correlated variable, and t is the target variable. Then learning rate, I told you. Then iterations, how many iterations we need. For example, here I have taken these many iterations, when I will show you later on. So then error threshold means how much error you need. Okay, how much error is okay for you. Okay, that is error threshold. So now I will take m equal to init m, so that I will pass from here and I will store in m and then c, init c. Then error values, I will make a list of error values and mc value, because I need to append these values and I return at the end an MC value. So main algorithm starts from here. For I in range of iterations, how many iterations are there? E equal to error. I will call error function from here. So it will pass m axis ct here. Then I will find the error, and if the error value is less than the threshold value, then what I will do, I will come out and say stopping gradient descent. Okay, then otherwise if it is not, then what I will do, error values dot append e. I will append that error value and MC. Then I will update the MC values, because now error is not less than threshold, right? So that's why what I need to do, I need to update M and C, so that my line gets more and more closer to the fit line. So MC values dot append, and I append MC values also now. So then I will return MC error values and MC values. So yeah, this is training set. So we are training it. Okay, so let me execute. Yeah, so now this is important, and now here the actual algorithm will start. I mean to say, we have discussed all the functions. Now here we will call the functions, that is mean algorithm, that is gradient descent. We will call this algorithm here now. Okay, so we will store, we know that it will return MC error values, MC values and all. Okay, now we will store it here, M comma C error values, MC values. Okay, so gradient descent, I'll pass these things. Init M, what is init M? I have taken it 0.9. okay, now what is init C? I have taken it 0. I can take anything, okay, initially randomly. Then learning rate, what is the learning rate that I need? I'll write it 0.001, okay, randomly. Then iterations, okay, let me make iterations 250, okay, I'll show later on. Then threshold, error threshold, then it is 0.001. so now this function will take time, because this is training the machine and there is a large data and it may take time. Now how to know the time? I will use this smart function, percentile time. So this will tell us the CPU time. So see, CPU time is 57.2 milliseconds and total time is 57.5 milliseconds. So if I increase the iterations like 0 0, okay, 100 times I have increased. Now see the time. Yeah, it is taking long. Yeah, you can see total time is 4.88 seconds. Can you imagine? So if you increase the iterations or data set, then the time to train will also vary. So now we have calculated M and C. Now M is fixed constant and C is constant. Now on we will take the testing data. Here I was taking training data. Now I will take the testing data and I will predict the values by putting it into the equation of line that we have calculated. Okay, now I have put the X test here, and then here I will wait 1 second. Yeah, for to be safe, it is again taking a lot of time. Yeah, so now I will calculate the mean error square, that how mean squared error and how much error it can give. It can give 0.019, that means 2%, approximately 2% error. Okay, so now I will depict it making the data frame. And what data frame consists? X test, testing data, and Y test means Y test, that the target value we have given for prediction, and this is the predictor data for that. Now yeah, see, this is the predictor. Can you see? This is 0.33 and this is 0.37. It is really very close, right? 0.19, 0.16, 0.44, 0.45. See, these are very close values. So this was actual value and this is the predicted value. So machine is predicting, right, what can be the price according to one correlated variable LSTAT. Now can I plot this predicted and testing? Yeah, I can do it. So see here, plot dot scatter for the testing data. This is LSTAT testing data and this is target data. Okay, testing data. So color blue I am taking. So these blue dots is represent the testing data, and then this is testing and this is predicted. So testing will remain the same and predicted will change. Okay, dependent variable will change. So predicted, and you can see the line passes through this. This is a regression line. Okay, so from here you can see. Yeah, so you could use func animations also. Actually it will make the video and then it will load to the HTML page in Jupyter Notebook. So if you are very much interested, you can just Google it and see. So func animation will show you this line changing when you run this gradient descent algorithm. So that line will show that how it is changing. That earlier maybe you have taken this line here like this, so it will change, it will rotate and it will rotate and it will come to this. So it will be like video only, animation. So you can do it yourself if you are eager to do it. So now we had actually normalized the data, right? So normalization was between 0 to 1. Okay, but initial data what the user had given was something else, right? So we again need to reverse that to the actual data, normalized data to the actual data. Okay, so now we will reshape to change the shape that is required by the scalar. Now what does scalar x scalar and y scalar expects is the vertical, right? Vertical data. So that's why we are reshaping this, and we are reshaping predicted values, all the values. Then we are passing it to x scalar dot inverse the transform. This function, okay, this function will take the array numpy array and it will reverse back to the unnormalized initial data. So this step is to reverse it back. So inverse transform function will be used here. Now x test scalar, scaled x test scale, yeah, again we are converting it to the real dimensions. Then from here, what is, yeah, PD. Now again I am making the data frame and I am showing you here. So this will take what, x text scaled, this is this one, means normal unnormalized data, okay, and y test scaled and predicted scaled. Earlier it was, see what it is, x text, y test and predicted. Now it is x test scaled and y test scaled and predicted scaled, then columns x, target, y and predicted. So yeah, you can see here 20, yeah, it is 20, 13, not between 0 and 1. Okay, yeah, that's all. Thank you guys. So this was a project from Skyfi Labs. So yeah, I enjoyed doing this project from Skyfi Labs. It was very interesting. So okay, thank you.